Before I introduce, it's been a long day. Before I introduce our final speaker of the day, I have a few short announcements, which I'm going to do in Hebrew. קודם כל, החוברת התקצירית של כל ההרצאות היום נמצאת גם באתר של האגודה לרעיונות וגם באתר של מרכז ספרא. אתם מוזמנים לעיין בהם. בנוסף, כפי ששמתם לב במהלך היום, חלק מההרצאות צולמו וגם הם יעלו בימים הקרובים לשני המקומות האלה, לאתר של האגודה לרעיונות לשפה ולאתר של מרכז ספרא. ואנחנו גם נפנה לדוברים ולבקש מהם מי שיסכים להעביר לנו את המצגות של ההרצאות וגם החומרים האלה אני מקווה שיעמדו לרשותכם בימים הקרובים. שוב, דרך האתר של האגודה לרעיונות. ובקשה אחרונה, מי שמעוניין לקבל את רשימות התפוצה וההודעות מטעם האגודה, מוזמן שוב להיכנס לאתר של האגודה. יש שם טופס מאוד פשוט שאפשר למלא ואת פרטי הקשר שלכם ונשמח לצרף לכם לרשימה שלנו. It is a great honor and privilege to introduce Professor CharlesPerfetti, our distinguished keynote speaker, whose talk is titled Reading Comprehension Skill, Why Word Processing is Central. Professor Perfetti is a world-renowned scholar of reading and literacy, whose research extends from the neural substrates of reading through behavioral psycholinguistic investigations into educational practice and evidence-based instruction. I want to take a moment to say that the late Professor Tzvi Brezhnitz, who died recently, was very happy when she heard that Professor Perfetti accepted our invitation. We're all very sad that she didn't make it to be here with us today and to take part in this very special event. Professor Perfetti earned his PhD from the University of Michigan and has been a professor at the University of Pittsburgh since 1967. He is currently a distinguished university professor of psychology, the director of the Learning Research and Development Center, which is a unique multidisciplinary center whose mission is to advance the science of learning by bringing together leading researchers in the cognitive, social, and educational sciences. Professor Perfetti has published over 100 peer-reviewed papers, has authored 7 books, has served as the president of the Society for the Scientific Study of Reading. He's a fellow of the American Psychological Association. He's a member of the American Educational Research Association, and I could take the rest of the evening telling you about his many achievements, but I'll stop here. During his long and illustrious career, Professor Perfetti has made numerous significant contributions to the scientific understanding of language and reading processes. These include his study of reading comprehension and formulating the lexical quality hypothesis, which stresses the importance of word-level representations in enabling higher-order comprehension. His comparative cross-linguistic investigations of reading, most notably in English and Chinese, have revealed universals of reading, as well as language and orthography-specific cognitive processes and neural substrates that support reading. Professor Perfetti's research into second language reading acquisition have furthered our understanding of how human cognitive and brain systems might use existing procedures to assimilate reading in a new orthography on the one hand, but can also change and evolve through learning to accommodate L2 reading in cases where the new system diverges significantly from the first language. Beyond these significant scientific discoveries, Professor Perfetti has an enduring commitment to articulating and disseminating the practical consequences of his work for literacy instruction, for the identification of struggling readers, and for finding ways to assist them. So, without further ado, I'm very pleased to invite Professor Perfetti.
Thank you, Anat, for that very nice introduction. Thanks for inviting me to the conference, and I want to thank all of you for being multilingual and allowing me to speak in English. So, introduce you to Pittsburgh very briefly. University of Pittsburgh, where I come from, can be said to be the birthplace of reading science. The fellow you see on the left side of the screen is Edmund Burke Huey, who in the early part of the 20th century, 1908, wrote a book called The Psychology and Pedagogy of Reading. He was the first chair of psychology at the University of Pittsburgh. His book is, to this day, stands, I think, as a brilliant description of the rough outline of how reading works. We've learned quite a bit since then, but almost everything that Huey had to say turned out to be held up as correct in the light of other evidence. And the building on the right is our iconic Cathedral of Learning. So I want to talk about the role of words in comprehension and begin with a big question, which is, what's the cause of reading comprehension problems? One answer is that comprehension problems are generally associated with problems in word identification and phonological skills. This association is consistent across languages, the correlations are high, and although one doesn't have to say decoding is the cause of such problems, the association makes this the most common type. However, there are also many cases in which there is an absence of decoding and phonological problems, and word identification is okay, and these are called specific comprehension deficits. Here's an example of a plot from data collected at the University of Pittsburgh by Nicole Landy in her dissertation. And the top part of the screen, I'm going to make a slight adjustment here. Screen instead of my screen, because my screen is too tiny. Whoops. All right. So in the upper left quadrant, what you see is adult readers who we have assessed their comprehension. Factor analysis gives us the comprehension component. That's on the x-axis. On the y-axis is the lexical component. And in general, what you see is a very strong, if you do the regression line, very strong correlation. I don't know exactly what the number is. But interest is directed at people in this upper left quadrant who could be characterized as having specific comprehension problems in the specific sense that their comprehension scores are lower than one would expect based on their lexical scores. Right? Their lexical scores are high. Comprehension scores are lower. There's another group this is the group, by the way, that people are studying. People who are interested in comprehension deficits that are not part of the general pattern of being associated with word reading, that's what they want to study. That group, 23% in our sample. Other samples will show the numbers a little bit less, a little bit more, but that's in the ballpark even among adult readers. This lower quadrant shows an interesting group that we are studying. I will not be talking about them today. We call them resilient readers. They're a smaller percentage, about 8%. Their comprehension is better than one can predict based on their word processing. Because then for them, the question is, how do they get good at comprehension if they don't seem to be so good at word reading? Since many people are interested in learning disabilities, I want to point out how reading comprehension deficits fit in the new DSM-5, which governs diagnostics in the United States. It used to be a category called the dyslexia. In the new way of classifying learning disabilities, dyslexia is out as a special category. And it's blended in with specific learning disorders that have different profiles. And one of them, highlighted in yellow, is difficulty in understanding the meaning of what is read. and that's the comprehension deficit. So not only is dyslexia, which is characterized by poor word reading and spelling, understood as a specific deficit, comprehension is increasingly believed to be something fairly specific and independent of other things. Well, the question is, if we use the dyslexia analogy, and you may or may not buy the claim that we understand dyslexia to be mainly due to phonological deficits, but a lot of people do, based on lots of evidence, that the main cause of reading disability is phonological processing system, then what's the major cause of comprehension deficit? Well, we have some candidates from comprehension research. For example, some people point out that the cognitive system is at fault in poor comprehension, that poor comprehenders have poor working memory, or they have poor cognitive control systems. So people are actively pursuing that line of explanation. Another line of explanation centers on the idea of the comprehension strategies, higher level processes that are not working well for poor comprehenders. Here, this includes things like failure to make inferences. Poor comprehenders are not so good at that. Failures at comprehension monitoring, and generally failing to engage reading strategies. The comprehension strategies approach is very big in many places, and it leads to sort of slogans like you see in these slides. The importance of predicting. If you want to understand, you should be predicting and making inferences. There are remedial programs that are actually following these kinds of procedures. And they may very well be right. I don't want to say in what follows that any of this is wrong, only that it's incomplete. And I take an approach that can be summarized. I have to have a slogan too, so it's called pressure points. In the diagram, the symbol's a little bit different. So all the pressure points coming into the reading system, and they're localized in the lexicon. So this diagram is a schematic that goes back to a paper I published some years ago and then updated to basically be a big overview of the reading system from visual input all the way to, on the left, visual input activates orthographic and phonological units, that's identifying words. The words are represented in the lexicon, you know about their meanings, their forms, their morphosyntax, and all of those aspects of words are important for comprehension. In comprehension on the far right you see parsing, text representation, situation model, the mental model of the text, and so on. But in the center is the lexicon. The lexicon is the pressure point. It's right in the center of the action. It's the output of word identification, and it's the input to comprehension. It's situated in a position where it's got to be important. There's the input arrows and the output arrows. In general, we always argue there's a kind of synergy between word understanding and comprehension. There's a little diagram that represents what I'm talking about, which I call the virtuous reading circle. If you're good at reading, this circle is virtuous. If you're not good at reading, it's not virtuous. But if you read and comprehend, you're in a position to learn new words, because we sometimes can infer meanings of words while we're reading. And as you learn more words, you acquire more word knowledge, and as you acquire more word knowledge, you get better. You can read words that you couldn't read before, and you get better comprehension. And so we have the nice virtuous circle. If you're not good at reading, as I said, it's not so virtuous. we've been looking at parts of this virtuous circle in our research. One part has led to the following general conclusion, that comprehension depends on understanding words and fitting the meanings of words into a mental model of the text. And we find in our research that more skilled comprehenders do this better than less skilled comprehenders. We've also looked at the sort of the reverse of that and concluded that learning words depends on understanding word learning events. You have word learning events when you read sentences or definitions. There are all kinds of ways to learn words in the course of making inferences about their meaning, and we find that more skilled comprehenders do this better than less skilled comprehenders. I wanted today to focus just on this one, that comprehension depends on understanding words. And I want to illustrate our research with studies of what I call word-to-text integration, or WTI for short. And these studies are done mainly through ERPs. Eye tracking is another way of doing this, but the key idea, if you want to study word-to-text integration, the processes by which, as we read a word, we do something useful with it, like integrate it to what we have just read, integrate it into the text. That's WTI. If you're going to try to study that, you've got to do it in a way that allows you to study one word at a time during reading. Eye tracking is good at that. ERP is good at that. And I'm going to talk about our ERP research. Most of you know about ERPs and EEGs, but I want to just orient us all toward the experiments that I'll be talking about in a minute. I'm going to make a lot of use of the N400 in the event-related potential. And what you see there is an idealized waveform with an arrow at 400 milliseconds. That's where the N400 will occur. That negative going part of the graph is a negativity that occurs about 400 milliseconds after the onset of a word. So in the sentence like Mary reached into her purse and pulled out a carrot, what we're seeing there at 400 milliseconds after the word carrot comes out, you get a negative deflection simply because it's kind of unexpected to pull a carrot out of your purse. It's not impossible, it can be done easily, nothing terribly odd about it, but it's not really very expected, and you tend to get an N400. On the other hand, if we have Mary, instead of reaching into her purse, she reaches into her lunch bag and pulls out a carrot, then we get that dotted line, a greater positivity, less negative, indicating that the word carrot is more easily integrated into the sentence with the lunch bag than it is integrated into the sentence with the purse. So I'm going to tell you about 3 ERP studies that we've done to get at WTI, the word-to-text integration. In these paradigms, we do comprehension of brief texts. We look for skill differences in WTIs across sentence boundaries. The second experiment and the third experiment, I'm going to tell you about how we try to get at the mechanism for how WTI works. This depends on the paraphrase effect. We've called this the paraphrase effect to capture the idea of integration occurring across sentence boundaries. Across sentence boundaries is very important in this work. A lot of ERP research focuses on processing sentences within a single sentence. But if you're going to talk about text processing, you have to have at least a couple of sentences, or else it's just sentence processing. So we construct 2 or 3 sentence texts and look at integration across the sentence boundaries. And here's Here's an example of what I mean by the paraphrase effect. So in the first sentence, there's a sentence that refers to a bomb hit the ground and blew up, and then the next sentence begins with the noun phrase explosion. The idea, of course, is that explosion simply refers to the event that in the first sentence has the words blew up. The next example, it's started to pour. You can begin that next sentence with the rain, and you understand immediately that the rain can be integrated with starting to pour. They're not the same words, but they integrate very well. Made a large financial contribution, the donation, and so on. Here's an example from the experiment I'm going to show you about. After being dropped from the plane, the bomb hit the ground and blew up. The explosion. So that's our paraphrase condition. We also have a condition, the easiest part of integration will occur when you actually repeat the word across a sentence boundary. So after being dropped from the plane, the bomb hit the ground and exploded, period, the explosion. So you ought to be able to integrate the explosion with the event exploded. They have the same morpheme. They're virtually the same word. So we call this an explicit condition. So that's a signal for explicit integration. It should be the easiest. And then there's a baseline, and unlike most baselines in the ERP research using the N400, there's nothing wrong with this sentence. It's perfectly comprehensible. It dropped its passengers off and left. The explosion, and you might say, well, wait a minute, it doesn't make any, it is actually kind of odd, but notice the sentence could continue. The explosion that people worried about never occurred, right? So this is not like a sentence. The classic kind of baseline in N400 research is the pizza was too hot to drink, right? Which is anomalous inside the sentence. It just doesn't, drink pizzas. These kinds of sentences in text research are not like that. The baseline is not anomalous. It's just that it doesn't lend itself to integration. So in order for you to understand the kind of the experiments, to get a feel for this, I'm going to show you what you would see if you were a subject in one of our experiments. Because it's ERP, you'll see the words presented one at a time, and you don't have to do anything here. Just passively look at the words and feel your brain integrate toward the end. So, after being dropped from the plane, there. So that was very, very easy, right? You can almost feel the integration process. And when it came to the word the explosion, it was just super easy. So we take the measurement on the word explosion. The question is, when you read the word explosion, if you're a subject of an experiment, we want to know about the ERP, the N400. In the experiment, that's kind of a benchmark for how we wanted to pursue, caused us to want to pursue how these effects work. We had this kind of comparison. So in the first row, you see the paraphrase condition, blew up followed by explosion. That's the one I just illustrated. Then there's the explicit condition with exploded followed by explosion. The result we found there was this N400 reduction. Now, the N400 reduction is the degree of positivity you get compared with the baseline, where you get some negativity. And our skilled comprehenders, these are adult skilled comprehenders, our adults showed strong effects for both explicit and paraphrase. So skilled comprehenders show an N400 reduction across a sentence boundary, even if you don't repeat the word. It's not exploded, explosion, it's blew up and explosion. And our less skilled comprehenders showed this effect only for the explicit condition. If you repeat exploded in the form of the explosion, you get a reduced N400. But for that case of blew up followed by explosion across a sentence boundary, we didn't find that effect. Here are the topological maps. Just because it's just so easy to see what I'm talking about. As you know, probably in ERP, topological maps, the positivities are the warm colors, like the yellows. The negativities are the cold, the purples and blues. And you can see the greater positivity in the skilled comprehenders on the word explosion across a time frame that starts at 150 milliseconds after the onset of the word, almost at the point of word identification, and persists through 500 milliseconds and then goes away. And you can see that less skilled readers did not show that effect, and we have called them, we've referred to them as showing sluggish comprehension. Less skilled readers are more sluggish in this integration process that we're trying to understand. An interesting result in this study was that we had another condition that I haven't mentioned yet about prediction and inference making. Notice you could have a sentence like we have on the right. After being dropped from the plane, the bomb hit the ground, but there's no mention of exploding yet, no mention of blowing up. But if a bomb hits the ground, you might say it's pretty likely to explode. So if prediction is what occurs as you comprehend, you try to predict what's coming next, you should see an N400 reduction on explosion, but you don't. In our experiments, you do not see a reduction based on trying to predict the word that's coming. You see it based on a word that can be made to be co-referential, refer back to the word in the preceding sentence. So prediction is important in many contexts, but I don't think it's the main thing that goes on in integration. So we've tried to, since this finding, we've tried to understand what it is that's going on when people are doing the integration. What are the cognitive mechanisms that are promoting integration? We've looked at memory, we've done listening comprehension comparisons, which are very interesting. We've studied WTI in middle grade children, and these are all very interesting, but I'm not going to tell you about them because of time. I'm going to tell you the two things I have checked off there. Studies in which we try to compare, determine whether the effect is due to words or to messages, the message level versus the lexical level, and expectancy versus memory. So let's start with the lexical level versus the message level. The WTI is really an interaction between a word and a message, right? Again, you just read a sentence, so you have a representation of the meaning of the sentence. That's the message, whatever that sentence means to that point. Now you go to the second sentence, and there's a word there. So it's the interaction between the meaning of that word and what you have understood about the sentence. Now, there are two things going on here then. That means the word meaning effects happen through the lexicon. So you read the word explosion and you know what it means. So, explosion, whatever explosion means, blew up. On the other hand, you have the representation of the message to that point. The momentary representation of a plane having dropped a bomb, and the bomb fell on the ground and blew up. So you have both of those events, and the integration is bringing them together. So it ought to be interactive in some sense. But when you do ERP experiments for comprehension, you wonder about the effects of word association. Maybe blew up simply evokes explosion in your lexicon. It's just like a word association, like up and down, or black and white, or just kinds of association. So we can take a look at that to find out how important it is. And the form of this question is really, is lexical association, which can be really strong. Say the first thing that comes to your mind when I say up and down is what you think of, right? That's really strong, that's what's driving the effect. And the way to put that question is lexical association across sentence boundaries, is it modified, even within sentence boundaries, is it modified by the message meaning? The answer has to be, of course. Otherwise, if I say, I love bread, but I hate butter, or I hate bread, but I love butter, those will have the same meaning. They have the same words. The syntax is what tells you the messages are different. On the other hand, it's the case that when you read a word, there's a brief period of activation of meaning that is not selective, and that there's a lot of association that's going on in the very early parts of comprehension, and so it's at least possible that comprehension depends very much on these lexical associations. Well, here's the kind of experiment we have done to get at this. We want to compare word association in a task in which all you have to do is judge whether two words have the same meaning, and compare that with a task in which words in which you're reading for comprehension using the same word. So, for example, storm and rain have a strong association when you look at the association norms. Shower and rain has a weaker association. So we can put those into a word meaning judgment. We simply ask you whether they have similar meanings, and you say yes or no. And we can compare them in our comprehension paradigm in the paraphrase effect, where we can have a sentence like, while Kathy was riding her bike in the park, dark clouds began to gather, and it started to storm. The rain ruined her beautiful sweater. That's a strong association. Or we could have, and it started to shower. The rain ruined her beautiful sweater. That's a weaker association. In the meaning judgment task, you do something like this. I show you word 1, like storm, and then word 2, rain, and you simply make a decision whether they relate to meaning or not. And the behavioral results look like this. You are indeed, in word meaning judgments, faster to make a meaning decision if the words are strongly associated than if they're less strongly associated. That's an important baseline observation. When we look at the ERPs, and we're recording ERPs while subjects make these judgments, you see that there is a, let's see what you can see. Boy, that's really washed out, isn't it? So, SA stands for strong associate, and WA stands for weak associate, and what you find is that strong associates are producing a greater reduction in the N400 than weak associates. Actually, this blue bar tells you that the difference between the N400 for strongly associated and weakly associated is correlated with decision time differences. You can sort of see the bar graphs in the 3 areas, but what I show up there is an electrode map with the arrows pointing to the graphs. The graphs are too washed out for you to see, but these boxes at the bottom, the bar graphs kind of show what's important. In each case, in each of these 3 areas, strongly associated words produce greater N400 reductions than weakly associated words. So everything works just the way you would expect in lexical association. Lexical association is important if you have to judge whether meanings are the same. Now, in a text situation, we want to know whether it's the same or whether it's different. Association strength affects word meaning judgments about text comprehension. Well, just to remind you about the text comprehension studies, you see these words one at a time, as the way I illustrated before, and the results you get look like this. You can't see, it's so washed out you can't see much, but you can see the bottom. Strong associate minus baseline, weak associate minus baseline, you can see that they're virtually equal. If you compare directly the N400 effect across word association, word meaning judgments, and text comprehension, you can see that strong association strength matters for meaning judgments. It doesn't matter in the text comprehension situation. So we're inclined to draw the conclusion that the WTI effect, by the way, was restricted to the more skilled comprehenders. The pattern of results I showed you was a little different for low-skilled comprehenders. And once again, we find that the N400 reduction, the word-to-text integration, is more in evidence for highly skilled comprehenders. So the summary from this study is that the N400 indicator of WTI is not affected by word association strength within the range that we used in our study. I'm not saying it would never be, it ought to be in fact, but it's pretty clear that it can't be the whole story. So these WTI effects have to have a message level component. That is, they have to depend to some extent about what you have understood from what you read. And that's important if we want to claim this is about comprehension and not just about word association. I want to move to final experiment that I'm going to tell you about, which is the following. An important issue in ERP research involving N400 has been, is this about prediction or is it about memory, or the way we put it, prediction versus expectation? So I think it's going to turn out that word-to-text integration is a mix of prospective and retrospective processes, where retrospective means memory processing. We want, what the reader has to do is attach word meanings or reference to a mental model of the text, and this is essentially a retrospective process. I'm going to illustrate that, what I mean, but the main point is that reading is a word-by-word process, and as you read a word, there's a retrospective process of connecting that with what you've already read. It's not about predicting, it's about remembering. It's about a memory system that provides information onto which you can integrate the word. So I can illustrate this with this diagram. So in this sentence, while Kathy was riding her bike in the park, dark clouds began to gather and it started to storm. So the blue cloud is a mental model. It's in a cloud because it's in your mind somewhere. It's a mental model of what the text is about. Not a model of what the words are, but what the text is saying, what the meaning is. And now the rain is going to come up. So the bottom arrow illustrates the possibility that as you are reading Started to Storm, you are getting ready for or perhaps predicting rain. So that's the prediction pathway. The memory pathway is going backwards. It says what's happening is that as you evoke rain, your memory search is for information that's already in memory that you've understood from the preceding sentence. And this we're going to refer to as updating. That is, you're updating your mental model such that what had been referred to as started to storm is now made somewhat more specific with the word rain. It's refining your mental model. Now, I know that some of you are interested in comprehension. I realize probably most people have been at the word level, and my work has been at both levels. But I want to emphasize the idea of comprehension as building a mental model in which, as you read sentences, as you read text, you construct specific references and events in these mental models. And I think we're getting some evidence that integration occurs at this level. I want to contrast that with this case of, I'm sorry, I didn't show this when I was talking. Once again, I was a slide ahead of myself. So this is representing the updating or refining idea, the rain referring back to what you just read. And here's the baseline situation. It's turning out that this is really interesting, the baseline situation, because a lot of our sentences are like this. When Kathy saw there were no clouds in the sky, she took her bike for a ride in the park. The next sentence begins with the rain. There hasn't been any hint of rain in that first sentence, unless you think every time you go to the park it rains. I mean, you might have that. And again, it's not that the rain is anomalous in that situation, because it could continue. The rain that the forecasters predicted never occurred, right? And weather isn't always right. So it's perfectly sensible. Keep that in mind, because it's going to turn out, I think, in the long run, that this is what good comprehenders are good at. They don't care that the rain doesn't integrate. They can integrate or they cannot. Call that shifting. Okay, so we get at this with forward versus backward association. In this experiment, the idea is we take word pairs that are asymmetrical in their strength of association. So, for example, take the word rage and anger. It turns out that if you ask people to say the first word that comes to mind when you say anger, they don't say rage very often. But if you say, what's the first thing that comes to mind when you say rage, they do tend to say anger. So rage to anger is stronger than anger to rage. And we exploit that fact in these experiments by having both forward and backward associations. So So here's an example with the rain storm example. Rain to storm is forward, storm to rain is backward. In this case, storm to rain is the stronger association. We're going to test forward and backward association both in meaning judgments on words and in text comprehension. And the behavioral data for semantic judgments, this again is that task in which all you have to do is say whether two words have similar meanings, and the time that it takes you to make that decision is less for a forward association. So in the case I gave you, rage, anger to rage is quicker to judge than rage to anger. Forward association is faster than backward association. When we look at the ERPs, we see that they align with what the decision times just showed us. Both left and right sets of electrodes show a greater N400 reduction, more positivity for the forward case than the backward case. That's more for the blue than the red, and those are reliable differences. So once again, forward association is important in meaning judgments. Making a judgment about the meaning of two words is facilitated if the first word evokes a second as an association. Again, the question comes, what about text comprehension? In text comprehension, this is the N400, one sees a different story. Here, the backward association is stronger than the forward association. You can see the positivity difference on the left very clearly, where red is positive, more positive than blue. Over here you might wonder, well, isn't it going down? But remember about ERPs, positivity and negativity is completely relative. There's no interpretation of it being below or above zero. The main thing is that in this case, there's really no difference. I said backward is greater than more than forward, and I'm not sure now that I look at that that's right. The overall effect is that backward is greater than forward, which you can see here in this comparison. This is a topological map, which makes it easier to see. You can see that word judgments, you have strong warm colors associated with the forward association. In the case of text, it's the opposite. In text comprehension, the backward associates are the ones producing greater positivity. So there's clearly a dissociation between making judgments about word meaning, which is an activity that occurs strictly in the lexicon, where you retrieve word meanings and compare them, and text comprehension, where the word meaning is retrieved, but it's not compared with another word, it's integrated with the ongoing text. One of the interesting things we're finding is that this backward association strength, the backward association effect is long-lasting. 500 milliseconds, 600 milliseconds, 700 milliseconds. Look at the reds and yellows in the backward association in the text comprehension. It hangs on for a while, and we think that's about resonance memory. One way to handle ERP data is to do what's called a principal components analysis, and I'm going to show you a clarifying result based on doing the PCA. What I'm showing you here is essentially the N400 effects for text comprehension, showing you where it says F, that's where forward was greater than backward, where it's B, backward is greater than forward. And what you can see is that there was one place around 400 milliseconds where one had a forward association. We think that represents the expectancy part of the N400. But on the left, you see a lot of, starting as early as 200 milliseconds, again around the point of word identification, appearing again at between 400 and 500, and again between 600 and 700, in which words that are backward associated are producing very strong N400 reductions. Here's a simple late left hemisphere positivity that's associated with backward association. That's what the red bar is. It's 600 milliseconds. The significance of this is that it's related to recognition memory. Recognition memory experiments, one also gets a lake positivity. It seems to reflect retrieving information, and that's what I think is going on here. What's happening in word-to-text integration is as you read the word, the activation of what you just read allows a memory retrieval that then is integrated with the word. So I put it this way: the backward effect suggests a resonant memory mechanism integration. Resonant in the sense that it's passive. You're not working to do this. It's not about working memory. It's about the availability of information in a resonant memory sense. We found some interesting correlations when we did this that are making me rethink how to understand comprehension skill a little bit. Those are correlations between offline text comprehension, standard assessment, and the N400 effects that I've just been showing. The main thing to see is that there is a high correlation, moderately high, 0.51, between comprehension and the baseline positivity. Now, the baseline is where there is no association between the two words. It's that case where there's nothing mentioned about rain, there's no implication about bad weather even, and then the word the rain begins across the sentence. And the positivity there is actually correlated with comprehension in a way that is forward and backward association are not. And that's making me reconsider the possibility that what's important in word-to-text integration that's related to comprehension skill is not worrying about about the word that doesn't fit in or a word that you didn't predict. If you're good at reading, you see that word and you go on to the next. You start building a new structure. So this is the diagram that I have in mind. So again, you encounter the word the rain. It has nothing to do with the preceding sentence. And you don't have some jarring negativity there. You just begin to build a new structure to see where rain fits in. This is speculative at this point, but I went back and looked at a lot of our ERP studies, and they're actually always there. You tend to use the baseline just as something to subtract. So we started looking at the baseline as something to pay attention to on its own, and we need other ways of looking at this, but it's an interesting possibility. So let me wrap up with some conclusions on the cross-sentence WTI. Our experiment suggests that word-to-text integration processes are driven more by lexically initiated integrated processes than forward inference. In other words, the words are what's driving this WTI effect. It includes both message level sources beyond just word association. This really is partly about the meaning you get out of the sentence so that it can be integrated with the word that you're currently reading. I didn't tell you about this. It's similar in listening and reading with some really interesting differences that I had to skip. And it reflects both expectancy and memory-based processes triggered by word reading. And what I showed you implies the memory processes actually dominate. It's the backward effects that are important. These WTI effects are influenced by a reader's word knowledge and reading comprehension skill in both reading and listening, actually. To go back to the bigger picture on comprehension skill, I pointed out that comprehension research has emphasized higher level sources of comprehension difficulty, inferences, and comprehension strategies, comprehension monitoring, and I do think all these are important. And I certainly encourage us all to try to understand how they can support comprehension. But I do think there's a little balance that's needed to start taking seriously the idea that word reading is a pressure point in the comprehension system, and that we need to pay some attention to the processes that retrieve word meanings and integrate them into the reader's mental model. I raised this sort of rhetorical question about if the major cause of word reading disability or dyslexia is the phonological processing system. What's the major cause of reading comprehension disability? And I think the answer is clear. Unlike dyslexia, we should not expect to find a single main cause. Comprehension problems have multiple causes because comprehension has multiple sources of information that it uses. But one of the causes may be the lack of facile word-to-text integration processes. And if that's the case, then what determines how a reader handles words so that they can be integrated when that's possible and the reader can go on when that's not possible? What determines this kind of facility? A couple of possibilities from my own past. One is the verbal efficiency idea, which says speed and automaticity of word-level processes affect input to comprehension. Another is a lexical quality hypothesis that says precise knowledge about word forms and meanings, flexible knowledge about meanings allow rapid access to words, and this is what allows quick fits into the meaning context of a text. Those are not completely independent ideas. The second is a way of explaining the first. I've come to want to explain speed and efficiency in terms of knowledge rather than speed of processes. But both knowledge and efficiency can be improved through learning and practice, and efficiency can be improved through speeded practice. And I know that Zviya Brezhnitz and I had a kind of resonant view of these processes, very compatible views about things like verbal efficiency and lexical quality. And of course, Zviya in particular emphasized that you could get better at the speed part, you could get better at verbal efficiency with practice. And if that's successful, then that should actually lead to better word-to-text integration. It could be that some of the effects of that training, which we're seeing on measures other than just word reading speed, could be building some integration processes. And I love this quote I want to conclude with from Zviya. We essentially tell the brain, hey, you can do better. And it does. So I want to give a little acknowledgement to my friends back in Pittsburgh, and thank you for your attention. Yes? Do I have time? Can I take a question or two or not? We have a traveling mic she's going to give to you unless you want to shout.
I'd like to ask about another element which is in the last slide. It's about memory, particularly about the baseline, when you have to hold the last sentence, which is not integrated with your new sentence, and then you found that there is an association between, there is correlation between reading skill or comprehension and this ability to do it in the right way. So we know that good comprehenders usually have also good working memory, and so it might explain that when you have this baseline example and you have to keep in your working memory the last sentence, and now to add more words which are not integrated yet, so it might explain the correlation you found.
So yeah, to make sure I'm getting it right, you're suggesting that one possibility is that the correlation in general between reading comprehension is going to be related to working memory skill. That's actually one of the things we looked at in an earlier study that I didn't talk about. And we didn't find any evidence of that. And I think one reason is, at least, that if you notice in the sentences that I illustrated in our studies, the context that was relevant for that first word across the sentence boundary were always toward the end. So they were in the most recent clause. And the most recent clause tends to be in working memory, even if you have a relatively low working memory capacity. And I would suggest that while working memory differences exist, and while they are important, their contribution to reading comprehension may be pretty well exhausted by their effect on vocabulary acquisition. Let me recommend a recent article by Julie Van Dyke in Cognition, in which she shows that working memory is not a factor in a comprehension task that she carries once vocabulary is taken into account. So I have, in all of my work, I've always looked at vocabulary correlations. They're always moderate. They're always the same as reading comprehension. Some of the experiments we've done working memory, I've never found a case in which working memory is more powerful than vocabulary. We always haven't had big samples to do what Julie was able to do to really partial things out. And that's only one kind of observation in a context in which, as we know, there are lots and lots of studies linking working memory capacity and all kinds of things. So working memory capacity is important, but it might be that once you have acquired a vocabulary, and working memory has affected that, it's the vocabulary itself. I think it's a good idea to always look for the more direct link. So a direct link to comprehension is what you know about the words. What you know about the words might have been influenced by your working memory capacity, your ability to take in information and do things with it. But I think it's still an open question, but we ought to keep an open mind about the possibility that there's more to life than working memory once you have learned some language and some vocabulary.
Thank you for this really wonderful talk. I wonder about your genre that you chose for your research. All of the examples came from narratives. That is, they focus on events and they focus on psychological relationships between people. And these are things that you represent in mind, and therefore you can predict or go back to. But the kind of text that we see children have to comprehend in school, informative tests, for example, about how you produce what kinds of scents, all kinds of scientific things, or, for example, expository texts, which are about abstract entities. These don't work that way. I wonder how you measure what you were measuring here, given different genres.
Well, I agree completely, and it's funny, in some contexts I'll make exactly the same point that you're making to others who are stuck on narratives all their lives, and not very good narratives at that. I mean, and in this context, I start with what I think will work, especially because it's a situation where you can exploit the mental model idea a little more readily, because you can talk about events and people, reference, and all kinds of things. But it's a black box, unknown how this kind of thing works in expository text. We have to assume that word-to-text integration is possible. We might not want to assume you have a rich mental model all the time, because you might have to struggle with the exposition a little more. And I think we need to try to understand that, and I encourage all of us, me included, to now that we've been able to track something in a narrative where it's easy to track, that it would be really useful to do it with more demanding text, or I'm going to guess you'll see even more exaggerated skill differences, because we know that's really where people struggle as they get out of the kindergarten of stories into the real world of tough prose in academic context in schools.
Okay. Thank you very much.
Thank you.
I want to thank you all for coming once again, and I'm looking forward to seeing you at the conference next year, whatever it might be.